Good evening. I'm David, and I want to welcome you to Knowledge in Progress, Episode 0. This is going to be the first video in our series and my first real YouTube production. Full disclosure, you'll notice me switching outfits in this video because it was recorded across 2 different days. I had some camera issues and decided to re-record a few parts of this episode. Before we dive into things, I want to introduce you to myself and to the channel. In my regular job as a professor, I teach ecology, biology, and marine science courses, but I've spent most of my life learning things, and I've been really interested in the process of learning. To be clear, when I talk about learning here, I don't mean just memorizing facts, right? To me, learning is the development of understanding, not just this accumulation and memorization of information. Too often, we only see the final products of learning. We see this carefully edited YouTube video or a scientific paper or a textbook, and we miss the work that went into generating that product. This can lead us down 2 different but potentially dangerous lines of thinking. The first is that learning is easy and clean, right? We see this nice polished work. And then when we try it for ourselves, it turns out to be a really messy process, and we think we're doing it wrong. The second is that learning is some magical process that's beyond our reach. This is also wrong, right? Anyone can improve their understanding through curiosity and the proper use of evidence, as well as some deliberate organization in the process. To solve this problem, Knowledge in Progress is going to be a community learning project where you can see what it actually looks like when an academic learns new things. I'm going to pick academic questions that I genuinely don't have full answers to yet, and research them live on camera. We're then going to organize our findings in an Obsidian Vault that we'll talk about in a little bit, and you will have public access to that. Over time, as we answer more questions, you'll be able to see this vault developing into a complex web of understanding as ideas from one investigation become relevant to other studies in the future. I'm going to make this public so that you can do a couple of things. One, you can review older investigations down the line. You can look back at what we've already done in the past. You can follow connections between concepts for yourself and see how different ideas connect to each other. And you can use it as an example for your own learning. One thing that I really want to show you is the messiness of this process. I'm going to make an effort not to cut out places where I get stuck, where I reach dead ends, or make mistakes. Instead, you'll get to see how to recover from those moments and how to learn from them. We're going to see how ideas change with new evidence and how confidence varies based on the quality of sources, as well as how to get from initial expectations to a well-researched answer. There's no planned ending to this process, right? Knowledge is always going to be a work in progress. First things first, I mentioned an Obsidian Vault. What's that, right? So Obsidian is a free note-taking software that I highly recommend. I use it all the time for my own learning. There's lots of great YouTube tutorials out there on how to use Obsidian, so we're not going to go into those details here. But I'll link a few useful tutorials in the description to this video. Note that you don't have to use Obsidian. You don't need this particular software. It's simply a tool that I like and that works for me. But you can use a whole variety of different strategies to organize your notes. We can go to the Obsidian website to download this. And let me change views here. This is obsidian.md. This is where you can download the software. It should automatically pick the correct version for your operating system. I'm running on Linux. If you're running on Windows or Mac OS, you should have a different button here. Click on that to download the file and install it. I've already gone ahead and downloaded and installed the file. So this is what you'll see when you first open up Obsidian. We've got a blank vault here. A vault is just a folder on your computer that stores your notes. So a little bit of a description of what we're looking at here. This is going to be a list of our notes. This is our contents tab. Right now, the only note that's in here is a welcome note that's created by default. We can see the contents of that note here. Off to the side, we have what's going to be called our graph view. As we create new notes, they're going to show up here, and they're going to be connected by lines to other notes that they're related to, so we can see how ideas connect to each other. The first thing we're going to do is we're going to delete this welcome note. We don't need it. We're going to hit delete. And we'll see that now our graph view is empty. We're going to close this for now. We'll open it back up in a little bit. We're going to create a new note. We can do that very easily. We hit new note. And we're going to call this note types. Obsidian notes are just text files. So down the road, even if we lose access to Obsidian, we can still open these in any program that can read text files, and we'll have access to our information. So this is a very future-proof approach. Regardless of what happens to the software, if there are computers and you have your files, you will be able to read these notes in the future. We're going to go ahead and change a couple of settings here. There's a little settings tab at the bottom. When we open this, we'll have a lot of options to change. And we're not going to go through all of these. Like I said, there's great YouTube tutorials out there. But one thing that we're going to do is go to Appearance. We're going to make this into dark mode just because I like the look of that better. And we're going to manage themes. There's a lot of aesthetic themes that are already built. Some are very complex, some of them are very simple. I like this one here, Obsidian Nord. To me, looks very elegant. It's minimalistic, and it gives all of our headers nice colors so we don't have to change. So we can just hit install and use here. And now when we close the settings windows, we see that we have a different color here. It's highlighted the row we're working on. I say this is a note, and so forth. If you want to make headers in Obsidian, you put a hashtag in front of it, and we can say this is a header. We can make subheadings, just put 2 hashes, and we'll say subheading, and so forth and so forth. Like I said, lots of options here. We can go way down into the weeds, but I'll link a tutorial in the description. We also want to install some community plugins. There's lots of core plugins already in Obsidian, but we want a few that are written by other people. And if we turn on community plugins and hit browse, we'll have access to way more than we could ever use. This is a good place to describe minimalism. We can go really deep into the weeds here, but what we're aiming for is a minimalist approach that's going to reduce the barriers to just putting words on the page. One of the things that holds back note-taking is spending so much time optimizing your note-taking platform that you're not actually taking notes. And I have gone down that rabbit hole. It's very easy. So we're going to reduce the barriers to putting words on the page by keeping things simple. We're going to make the notes more future-proof. We want them to be readable in other software. And some of our plugins are going to format our information in a way that's not really human readable. We also just want to focus on the knowledge rather than on the software. That said, we are going to download one called Linter. Linter is very powerful. It helps automatically format our files. We're going to install that, and we're going to enable it, and we'll have options to control some of our formatting. I'm going to continue installing a few more plugins, and then we'll come back once I've got the settings set up so that we can look at how to actually use this platform. All right, so I've finished setting up the rest of the Obsidian Vault for now. And what I'd like to do next is go over the different types of notes that we're going to be using and kind of how we are going to organize this. So one type of note that we're going to use is going to be the question note. These are going to be notes that ask questions, and they're going to document the process of answering them, and they're also going to keep track of our current answer. Questions are going to be the starting point of this investigation, right? Motivation for learning is going to come from curiosity. And as a result, if we don't know what question we're trying to answer, it's going to be very difficult to learn something. So we're going to start with questions. The next note type is going to be what we're going to call a concept note. These are going to provide knowledge. They're going to store knowledge about a particular topic. So answering a particular question might involve us first learning about a few different concepts. And we'll see an example of that moving forward. So concept notes are going to be kept separate from questions. Because concepts can be useful for multiple questions, and questions could use multiple concepts, right? So let's actually make a note of that. Concepts can be used to answer multiple questions, and questions can be based on multiple concepts. Now, as we're learning about concepts, we're also going to need to keep track of our evidence, and this is where source notes come in. Keep track of evidence. We're not going to put a lot of information into here. We might jot down some rough notes as we're reading a paper or a book chapter, but we're not going to be doing a lot of polishing in here. We're going to just keep track of the sources we used so we can provide evidence for the statements we make in concept notes or in question notes. We can make these types of notes using templates. You'll see that I've created a templates folder here. If I open it up, there's a bunch of templates files in there already. So let's make a concept note. We're going to create a new note. We're going to call this some concept. And in order to apply the concepts template, we hit Control P to open our command palette. And we will want the Insert Template option. We're going to click on that. And I made a mistake. I forgot to activate my templates folder. So let's show you how to do that. Go to the Settings button. We're going to go to Core Plugins, scroll all the way down to Templates. There's a Settings option here, and we want to select our Templates folder as the location where templates are. Now we can insert a template, and we want the template for a concept. And you'll notice that it immediately fills in a bunch of headers, right? For any concept, we're going to need a summary, just a quick definition of what it is we're talking about. A discussion, this is where we keep track of new information as we find it. Any open questions we come across, these might be questions that I don't know the answer to. These might be questions that the scientific community as a whole doesn't have an answer to yet. And I also like to keep references to the Wikipedia and Wiktionary pages for a concept. These are not sources you would cite, but they're good places for a quick review if I haven't looked at a concept for a while, to just refresh my memory before I start diving deeper. There might be other sections we want to add later, so I'm just keeping this list for myself to remember that these are options. I've created similar templates for question notes and for source notes, and we'll see all of those come into action as we start researching our first real question. So the first question that we're going to investigate is the following. Why are ecosystems more stable when they contain more species? I'd like to put a question mark on the end here, but unfortunately question marks are not allowed in file names in Obsidian, but it's clear enough what we're trying to do. Now this needs to be a question note, so we're going to open our command palette, insert template, and we want the question template. So now we have our framework with which we can begin our investigation, and we can move forward from here. Now, as we answer this question, we're going to have other ideas. We're going to call them concepts. So we have questions and we have concepts. Concepts are ideas or things that we want to describe and keep track of, right? So for this question, why are ecosystems more stable when they contain more species, we might want to explore containing more species. So let's look at biodiversity. We want to look at what is an ecosystem. Let's see. We also probably just want ecological stability and so forth, right? So we have these concepts that we're going to have to be able to describe in order to answer the question that we've got, right? Why are ecosystems more stable when they contain more species? We have to know what it means to contain more species, to be more biodiverse. We have to know what an ecosystem is, and we have to know what we mean by stability in this case. So what are our initial thoughts? This is a great place to start. We might be completely wrong about this, and that's a good thing to know, right? If we know that our initial understanding was wrong, that's going to give us a baseline sense for where we are in our journey of learning. So my initial thought right now is going to be something like, if there are lots of species in an ecosystem, then if a species disappears, there will be others that can fill the same role. All right. I can spell. There we go. Okay. What we need to learn then, again, is what we put here. We're going to have to define the key terms in this question, right? So ecosystem, let's actually put that first. All right, that's the first word in the question. There we go. And we'll move biodiversity to the end. All right, so we have ecosystem, we have stability, and we have containing more species. That's going to be our starting point. Now, here's a trick that I really love, and that is that Wikipedia is a wonderful place to start. So we're going to do that with ecosystem. Now, one of the beauties of Obsidian is that notes can link to each other. To make notes link, you select the word and you hit the open bracket twice, and you'll see it's changed color now to red, and if I highlight it, it turns a little bit brighter. If you click on a link, it will either open the note that you're linking to if it already exists, or if it doesn't exist yet, it'll create a blank note like this. Now, ecosystem is a concept, right? So we're going to open our command palette, insert template, and we now have our concept template. So we have a few things to look at, right? We have our summary. This is our definition. We have a discussion, and we have any open questions. So from here, we could go ahead and let me go to Wikipedia. You may have been told that Wikipedia isn't a valid source. That is true for most types of writing, right? So if you're writing an essay or you're writing a paper, we don't cite Wikipedia. But Wikipedia is a wonderful navigational tool. It'll give you an overview of some starting points in terms of doing your research. So let's search ecosystem. So we have here an ecosystem or ecological system is a system formed by organisms in interaction with their environment. And there's a link here to a source. This looks like it's the Principles of Terrestrial Ecosystem Ecology by a bunch of authors. So that gives us a sense here, right? So we have the organisms in interaction with their environments. Let's see, we have a definition tab. That might be useful. So we click on that. Consists of all the organisms and abiotic pools or physical environment with which they interact. So we have all of the living things and the non-living things with which they interact. Let's go ahead and put that here in the summary. Let's put the Wikipedia link here. So we're going to go ahead and copy the URL to Wikipedia. These, by the way, are clickable. If you paste them in, it'll open up Wikipedia. So now we have a reference here. And we can go back into Obsidian and we'll say all of the organisms in an area and the non-living things with which they interact. Ideally, you want to use your own words as much as possible rather than copying and pasting from another source. Let's also look up a Wiktionary definition. So we'll say Wiktionary. Wiktionary is a wonderful free dictionary tool. Again, we don't cite it, just like you don't cite dictionaries. But let's get a sense ecosystem of what we've got here. So we have the etymology here, right? From eco and system, that makes sense. Coined in 1935 by Arthur Tansley. And here's our definition. A system formed by an ecological community and its environment that functions as a unit. That is a little bit more technical than our other definition, but we've got it here on number 2. The interconnectedness of organisms, plants, animals, microbes, etc., with each other and with their environment. So we're going to go ahead and copy this. In case we ever want to look it up again, we'll stick that in here. There we go. So all of the organisms in an area and the non-living things with which they interact. And we can, as well as the interactions themselves, right? We can add that in. We saw that in the definition. We're going to have to find some sources to back this up, but it's a good starting point here. So we'll leave the discussion for now. We'll get back to it, but we'll go back to our question. Note, by the way, now, if we're in our question, we can click the ecosystem link, and it brings us back to this note. We're also going to have to define ecological stability, and we're going to go ahead and make a link there. We'll make a link for biodiversity. And let's see, so ecological stability is the next note we're going to have to create. So we're going to create an empty note, as before, open the command palette, insert a concept template. Again, we're going to have to figure out what this actually means, right? So let's see if there's an article on this. Ecological stability. There we go. There is a Wikipedia article on this. There's an article for everything. An ecosystem is said to possess ecological stability if it is capable of returning to its equilibrium state after a perturbation. So that means that if something changes, right? Perturbation means something changes, the ecosystem will go back to the way it was, right? Or does not experience unexpected large changes in its characteristics across time. So this means that if there's a wildfire or something like that, a stable ecosystem will recover very quickly and look similar to the way it was before the wildfire, whereas an unstable ecosystem would have a harder time recovering. So let's go ahead, just like we did before, we'll copy the link. And our summary for now. And these summaries are also flexible. As we learn more, we might update these. But we're going to say something like an ecosystem is stable if it can recover quickly from, let's see, I don't want to use the word perturbations here. Let's make this a little bit more natural sounding. We'll call those small changes. All right, so we're going to have to get more than this, right? This is a bit vague, but it's a starting point. We'll go back to our question, and we'll also create a biodiversity node. Same thing as before, command palette, add a template for a concept. And now we go back to here, Wikipedia. And what we're doing here is setting a framework, right? So we're defining our key terms so we know what we're talking about. And we're creating a framework with which we can continue. Oh, this has a definitions tab as well. That'll be useful. So we can click on that. Biologists most often define biodiversity as the totality of genes, species, and ecosystems of a region. That is a bit broad, but biodiversity is a broad topic. And so let's see, totality of genes, species, and ecosystems in a region. So let's see if we can phrase this a little bit differently. We're going to say that this is the sum of all of the species, genetics, and habitat types in an area. Yes, I know that habitat type is not synonymous for ecosystems, right? We could. Actually, let's make a learning moment here. We're going to leave habitat types in there, or do we want to leave that in there? Maybe we don't. We'll actually go ahead and go back to ecosystems. Because now we can link these together. And we can click, this needs to be ecosystem. And it should show us the format. Now, ecosystem is singular. We want this to look plural. So if you put a pipe symbol here, we're going to say ecosystems. Now it displays the word ecosystems, but if you click on it, it goes to the ecosystem tab. So go back to biodiversity for now. So we've got the Wikipedia entry. Let's get the Wiktionary entry for this as well. I skipped that for stability because I highly doubt that there's going to be one, but let's check anyway. No, it's not. Okay. But we do want biodiversity. The diversity, well, that's helpful, isn't it? The number of and variety of species of plant and animal life within a region. So that's a slightly different definition than what we had before. But we'll add the link here, and we can refer back to it in the future. Again, you would never cite Wikipedia or Wiktionary, right? Just like you wouldn't cite any encyclopedia or any dictionary. But it's good to know where to find them if we need them. All right. So that is Wikipedia. Wikipedia is a wonderful orientation point. Now, one of the cool things here is that if you scroll to the very bottom of an article, there are all these references, right? So if we want to find actual sources that we can cite, these references are going to be useful, right? And we can see which ones they are by hovering over these numbers. So we have a textbook here. This is McGraw-Hill Education, Intro to Environmental Engineering, Biodiversity Evaluation Tools for European Forests, and so forth. So we can find these sources as we need them. So let's have a look at this question again. We've created some of the notes that we need. And now we're going to investigate our question. So let's find some references. One of my favorite places to find references is Google Scholar. I use this all the time. So let's look for a definition of biodiversity that we can already use that is actually got a source that we can cite, right? We can't cite Wikipedia. We need to find another source. So if you search, in this case, biodiversity definition in Google Scholar, not every source here is going to be a peer-reviewed article, and we'll talk about peer review in another episode, but in general, that is like the gold standard for something you would want to cite. Biodiversity, definition of sounds like it would be useful, except this is an encyclopedia, right? It doesn't get us quite as far as I'd like. Defining biodiversity. Notice that some of these files have links on them, right? If there's a link here for you, that means you have access to it. If you're logging in through a university account or a college account, you'll probably have access to a lot of papers. If you are not on a university or college account with Google, then you may have to find these papers somewhere else. It's a little bit harder to get a hold of them, and I can do an episode on how to find papers through public libraries and other sources. There's lots of ways to get access to sources, right? So we have here, what is biodiversity? That sounds like it would be great, but we don't have the source available right now. We could interlibrary loan this, but let's look at this one here. We got biodiversity, concepts, patterns, and measurements. And this says something about a political definition of biodiversity. That sounds kind of cool. So we'll open this up, and it will start thinking, and that's thinking a suspiciously long period of time. So maybe that's a bad link. If you ever get a bad link, you can click on this all 8 versions in this case. We don't want to translate. And this link here seems like it's a little bit weak, but there's a princeton.edu link here that we can follow, and it'll get us the access to this file, right? So this actually looks great because right away when I open this, I see a bunch of definitions that we can use, right? And there's a definition here for biodiversity. Now, this is a source, right? This is a source that we want to use. So let's back this up again. And to get the citation, we go to the little cite button here, and we want a BibTeX citation. This is not a great example because it's actually missing a lot of information, but we're going to go ahead and copy this and go back to Obsidian, and we're going to create a new note for this source. And we're going to leave the title off for now, but we are going to add in now our source template. And where it says no valid BibTeX entries found, we're going to paste this information. All right, so we have the title and we have the author. That's great. And usually we get a citation key as well. We're going to copy that and we're going to make that the title of this note so we can find it again. Now, opening this file, this is a chapter in a book, right? So let's see if we can find out what book this is. Sometimes at the bottom of the page there will be a header, but I don't see that here. So we'll back up a bit. And let's check a citation on one of these earlier links. Okay. So this is in the Princeton Guide to Ecology. So we can actually search for the Princeton Guide to Ecology. And it should link us to the book, right? So there's a book here called the Princeton Guide to Ecology. We need the citation for that. So we're going to copy this. Now, most books, you would cite the book itself. But if you have a book that is an anthology of single author chapters, right? Here there's one author who wrote this chapter. Then it's acceptable to cite the chapter instead. So that's what we're going to do here. So we're going to paste this down for a second. And of course, I chose a really complicated one to teach you with. So give me a second to pull this up. All right, so because this is a title in or chapter in a book, this is not an article. This is going to be in collection. And we'll see other examples moving forward. The title and the author stay the same, but then we're going to add in a book title. And we're going to actually copy all of this down. There we go. So now we have the citation for our source. Why did we save this? We saw that this had good definitions for a lot of terms regarding biodiversity. All right, so let's have a look at these. So the definition for biodiversity here is the variety of life at all levels of organization. So that means species, family, phylum, kingdom, whatever you want to look at. Kingdom's probably a little high, but this could be species. This could be genetic diversity, right? Classified both by evolutionary, so phylogenetic, or ecological or functional criteria. So how many species are there that eat plants? How many of them browse on algae? How many of them are decomposers, and so forth? Now, we want to put this into our own words, but for reference, what we can do is we can copy and paste this, and we show you how to put a quote in here. Our key takeaway, going to hit a greater than symbol, square bracket, and an exclamation point. Then we're going to type quote. This is going to create a little callout box that's called quote. And when we hit return, we're going to get a new arrow. Everything that has an arrow in front of it is now going to be part of that quote. And we're going to clean this up so we can read it. And if we want this to be bold, we can actually select it and put 2 stars around it. That's one of the beauties of Obsidian and Markdown in general. We can bold things very easily. So we've got this idea of biodiversity. This is already going to tell us that there are a lot of different definitions that can be used. So let's say that it has to do with the, has to do with the variety. What does this mean? Of living things, regardless of how these, no, maybe not regardless. I don't know if regardless is the right word. Variety of living things, categorized, instead of as either taxonomically or functionally. No, it should be 2 L's. It just doesn't know what taxonomically is. Okay. And there's other definitions there too that we can use. So we can go back to the source as we need it. So now we can go to our biodiversity source and add a section in the discussion. So this is going to be the variety of organisms, of life, right? Did I type species by accident in that source? No, of living things, okay. The variety of life in an area, regardless of how we choose to categorize that with a Z, that life. Now, all right, so we put a bracket up arrow, so caret, and then we can click on new footnote. And this is going to be our coal well paper. So we're going to put 2 square brackets. We can select the article that we want to use. Now, if we scroll to the bottom, we have a link to our source. And we can also now link this so we can go back and forth easily. Now let's look at another source. Let me fix my camera here so I can stretch my back and work sitting properly. There we go. Now I'm too low. All right, so we also need to have a definition for ecosystem resilience and how it connects to biodiversity, right? We want to actually answer the question here. So let's go to Google Scholar. We're going to leave this one up. We're going to potentially use that again. We've got a bunch of extra tabs open that we're going to close, and we're going to search. Now we're going to search for ecosystem resilience biodiversity. That should be what we need to find our answer. And right away, we get a source here called ecological resilience, biodiversity, and scale. That looks promising already, right? It's got resilience and biodiversity in one title. We've got a couple of other ones here that look like they could be useful. And we have access to most of these. So let's go ahead and just use the first one for now. What we'd want to do is read through them. All right, so let's have a look. So we have some information here. Species perform diverse ecological functions. That might be useful. The idea that species richness here is just the number of species in an area, produces ecological stability was originally proposed by Darwin in 1859, and then reiterated in 1955, and we've been working on it ever since. Oh, here we go. This looks very good. Models of ecological organization. So many competing models attempt to describe how an increase in species richness increases stability. That's a starting point. We divide these models into 4 classes. We have species richness, diversity, idiosyncratic, rivet, and drivers and passengers. So we can probably answer our question just off of this paper. It looks like it has an overview of the different explanations. So the first model here is going to be species diversity. This is proposed by Darwin. So let's go ahead and we're going to go ahead and make this a little bit smaller and see if we can keep, maybe not that small. I'm trying something here. All right, so let's start taking some notes here. We'll say 4 competing models. We should cite this source. We're going to need to cite this source. So let's get the citation here. So we go to cite, BibTeX. This looks much more reasonable. We have the title, the authors, the journal, volume, issue, etc., etc. So we could just copy and paste this. I'm going to create a new note. We're going to put the source template into this and paste our BibTeX. Now we have our article title. The article key, the citation key, we're going to put that in as the note title. And this is where we're going to be working. Models of relationship between biodiversity and ecological stability. So we go back to our source here. We're going to say species diversity model. And let's see what we want here. Idea was formalized by MacArthur, who proposed that the addition of species to an ecosystem increases the number of ecological functions present, and that this increases stability of an ecosystem. Oh, and there's a figure. Let's see what figure 1 looks like. There we go. So as we increase the number of species, the stability goes up. And we can see that at low numbers of species, there's only a few ecological functions that are being performed. And as a result, it's less stable. As we add more species, more possible functions are being performed, so we get higher stability. That makes sense. So let's copy this as a quote. So apparently this is not particularly well supported, right? It says, no investigations of the relationship between richness and stability have indicated that additional species continue to increase stability at a constant rate, indicating that the species diversity model is excessively simplistic. So let's make a note here. Not scientifically why is supported, overly simplistic. We'll make a note here saying that each species performs a function, more functions being performed, increase ecosystem stability. And we can actually just take this over to our, well, let's not, because this is too simplistic. We know this is probably not the answer. So the next model is this idiosyncratic model. So we're going to make a new header here. Is idio spelled with an I or an E? With an I. Proposes that strong ecological interactions among species result in an ecosystem that is variable and contingent on the particular nature of interspecific interactions. So we're going to copy that down. That looks useful. So what this is saying is that it's not enough to say how many species there are. We actually have to look at how they interact with each other. So what we're going to do here, I realize my shoulders are being cut off on the camera. Let's fix that. So we're going to say that the stability produced by the addition of new species depends on how those species interact with others that are already there. So we have an example here. Fire ants have had great impacts on the ecosystems of the southeastern United States, but a very different role in the Pantanal of Brazil and Paraguay. So the fire ant addition in one system is going to have a different impact on stability than others. Oh, and we have an example here. As we add more species, sometimes stability goes way up when we add new species. Some species, maybe fire ants, for example, can reduce stability, and then another species increases it again, so it depends very much on the relationships. Then we've got the rivets model. Evidence suggests that the effect of species removal from or addition to an ecosystem varies. That lines up with the idiosyncratic model. The rivet hypothesis likens the ecological function of a species to the rivets that attach the wing to a plane. Several rivets can be lost before the wing falls off. So essentially here, there is some threshold number of species that we could lose without the entire ecosystem collapsing, but if we remove too many, then we have problems. So in this case, if you have more species, it's like putting more rivets on the wing of a plane, meaning that you can lose more before you hit a point where it's no longer stable. So let's put that in here. There is some minimum number of species necessary for ecological stability. Having more species means that more can be lost before the ecosystem collapses. And then there's the drivers and passengers hypothesis. Ecological function resides in driver species or in functional groups of those species. A driver has a strong ecological function. These species structure the ecosystem in which they and other species, the passenger species, exist. Passenger species are those that have a minor ecological impact. Let's see. Since most ecological function resides in the strong influence of driver species, it is their presence or absence that determines the stability of an ecosystem's ecological function. So we're going to paste this in. So you can see that as we're going through, right, we are starting to build up this note with the key takeaways of this particular source. And we're already starting to see that we're getting an answer forming. So in this case, we can say something like, some species add a lot of stability while others don't. And we can say, does that mean that if we have more species and lose one, it is more likely that the species lost is a passenger rather than a driver, meaning that the ecosystem's stability is not greatly reduced. So we're starting to get an answer to a question. We are also starting to run out of time. I was planning on this being a 1-hour stream, and it looks like we are pretty much over that. So we're going to continue with this next time. But what I want to show you is a beautiful tool in Obsidian. Now we're going to just linger